Hi, I'm Mini from EC department. Now I am explaining the topic DC machines. This topic was taken from electrical machines. Okay, DC machines. What is DC machine? It's a electromechanical energy. Okay, what is that electromechanical energy? Energy conversion between electrical energy and mechanical energy. That is electromechanical energy, right? If we convert electrical energy into mechanical energy, we can say that is a motor action. Example fan, water pump, mixer grinder, etc. If mechanical energy is converted into electrical energy, we can say that is a generator action. Okay. So what's the example for generator action? Power plant, wind turbines, etc. Okay. In wind turbines, what's meant by turbine? It's the machine that converts energy of fluid. Fluid in a sense, water, steam, air. Okay. That energy into mechanical energy. Okay. So next principle. So these DC machines are worked on the principle of electromagnetic induction. We know already we discussed that DC machines indicates DC generator as well as motor. Okay, both will be work on the principle of electromagnetic induction, but in DC generator, that is Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? Whenever there is a change in magnetic flux, it linked with a coil, an electromotive force is induced. We can say that electromotive force is EMF. Okay. So that is what Faraday's law of electromagnetic induction. Next, DC motor, it works on the principle of Lorentz force. So we should know what is meant by Lorentz force. Actually, this Lorentz force is the force which is experienced by a charged particle. Okay, when it moves in an electric field or magnetic field, we experienced one field. No, that that field is Lorentz force. Okay, simply we remember a moving charge in a magnetic field. It feels a force. That feels is what? Lorentz force. Okay. So next, construction. Okay. So we know in DC machine, if it is generator or motor, both construction will be the same one. Okay. So how to construct it? So generally, two main parts are there. Okay. What are the main parts? Stator and rotor. Okay. So first one, stator. In the stator, we can say stator is the stationary part. In the stationary part, it consists of three main parts. What are they? Yoke, pole shoe, and core, then field winding. Okay. So next one, rotor, which is the rotating part. It consists of armature core, armature winding, commutator, brushes, shaft, etc. So next we discuss one by one. Okay. So this is the structure of what? DC machine. Okay. So initially I explained that two major parts are there, right? What are they? What are the major parts? Okay, stator and rotor, isn't it? So in stator, so many parts are present, right? The first one is yoke. Okay, so what is yoke? Actually, see the outer frame. Okay, so see the diagram carefully. Outer frame is the or outer cover of DC machine is the yoke. Okay. Simply we say it's the body of the machine that holds all parts together and provides a path for magnetic flux. Okay, what is the main function of yoke? It gives the mechanical support. That is, it holds poles, armature, and other parts Then it gives the protection. How it give the protection? That is, as we explained, that this yolk gives the protection. It's one of the function, isn't it? It protects the internal parts from dust, moisture, damage. Okay. And next one, this yolk provides low reluctance path. So what is low reluctance path? Have you heard this word, low reluctance path? In this, it is one of the path, okay, that allows magnetic flux to flow easily with little opposition. Okay. So we know this yoke materials are iron or steel, because this iron or steel having low reluctance path. Okay. uh, why we are used this iron or steel means, if we used air have high reluctance path, it's difficult to flow the flux. Okay, that's why the yoke materials are iron, they made using iron or steel. Okay, yeah. Then for small machines, this yoke are used only cast iron. Okay, but large machines they used cast steel or rolled steel. Okay, the steel is preferred because it has better magnetic properties. Okay, actually this yoke has two types: solid yoke, segmented yoke. Okay, so simply you remember yoke. Yoke is the outer frame of DC machine. It provides mechanical strength and magnetic path. It's made of cast iron or steel, and it supports field system. Okay, and the next one, poles, pole shoe, and pole core. So first we understand what is pole. What is pole? It's the parts of a DC machine. Okay, that produce that magnetic field. Actually, they are magnets which are present inside the machine. What is the main function of pole? It produces magnetic flux and supports field winding and helps in energy conversion. Okay. Next, see what is that pole shoe. Okay. So sorry, pole core. Okay. So what is pole core? Core. That's the central part of the pole where the field winding is placed. Okay, it is the main body of the pole. The main function is it carries field winding. It provides path for magnetic flux. It's made of soft iron or steel. Okay, next one, what's that? Pole shoe. See the diagram? This is the bottom part, right? So we can say it's the wider bottom part of the pole which is attached to the pole core. Simply we can say it's the flat spreading part of the pole. What is the main function of this? It spreads magnetic flux uniformly, and it reduces flux leakage and provides larger area for flux distribution. Okay, so this is about pole, pole shoe, and pole core. Okay, yeah. So simply you remember what is pole, pole shoe, and pole core. Poles are present inside the stator, and these poles are the magnetic field producer. Okay, pole core is the middle of the pole, which is placed in the or located in the middle of the pole. Okay, it holds the winding and carries the flux. Pole shoe, which is present the end of pole, it spreads the flux uniformly. Okay, I think you all understand, right? So shall we move the next one? What is that? Field winding. What is field winding? It's the coil of insulated copper wire wound around the pole core of a DC machine. What is that? That means the coil that produces magnetic field when current flows through it. Okay, it is placed on the stationary part, not rotating part. Okay, it is made of copper wire with insulation. Actually, we named one that is enameled copper. What is that? The copper wire with protective insulating wire or enamel coating. Okay, that we say that enameled copper. Okay, so many types are there. Okay, series field winding, shunt field winding, compound winding, etc. Okay, so what is that series field winding? If it is connected in series with armature, you can say series field winding. In that series field winding, it carries full load. Okay, so it consists of thick wire with full turns, And if it is shunt field winding, which is connected in parallel, it carries small current only and it consists of thin wire with many turns. What about compound winding? It's the combination of both series as well as shunt. Okay, so for better performance we are used to this compound winding because both actions are present inside this, right? Okay, now what's the next one? Armature core. Okay, what is armature core? It's the rotating part of DC machine, right? It consists of slots for winding, and it's made of laminated steel. It reduces eddy current losses. So we have one doubt, right? What is the eddy current loss? Actually, it's the current only. It is circulating current because in coil the current will flow in circulating path, right? So in that circulating current, there is some unwanted currents flow in the core, right? It produces heat that causes energy loss. That we say about eddy current loss. Okay, this armature core provides magnetic path, right? Next one, armature winding. There is the winding where voltage is induced and current flows. This where this armature winding placed, it's placed in slats of armature core which is connected to the commutator. How it made this armature winding? It's made of enameled copper wire. Okay. How it works? This armature rotates inside the magnetic field. When the conductor cuts this magnetic flux, we know, according to Faraday's law, EMF is induced. Now the current flows through the circuit. Okay. If in this armature winding, two windings are there, lap winding and wave winding. What is that? If the number of parallel path is equal to number of poles, we can say lap winding. Okay. If the number of parallel path is uh, constantly 2, okay, that is that we say that wave winding. Okay, the slap winding is used for high current low voltage conditions, but wave wind is used for low current and high voltage conditions. Okay, so these are about what armature winding. Next, commutator and brushes. Okay, commutator. First we see what is commutator. It's the mechanical device used in DC machine. This commutator is used to convert AC into DC. How it operates? Armature generates AC internally. We know what is AC. AC is the alternating current, isn't it? That alternating current is introduced or produced or generates internally, but the commutator reverses the connection every half rotation and the output is DC current. Okay, so one of the part associated in commutator is brushes. These brushes are stationary carbon blocks. Okay, why carbon is used here? Because carbon is the good electrical conductivity. That's why used this brushes as stationary carbon blocks. Okay, so what is the main purpose of this? It will collect or supply the current. In generator, how the brushes are introduced? What is the main purpose of brushes in generator? It take current from armature. But in motor, the brushes used to supply current to armature. Okay, so both will ensure smooth current flow between moving and stationary part, or rotating and stationary rotor and stationary part. Okay, the next one is shaft. What is shaft? It's the rod that carries rotating parts and transmits mechanical power. Okay, actually this shaft is placed at the center of the machine. Okay, why it is placed at the center of the machine? Because if this shaft is connected to armature core and commutator. Okay, so it will supported by bearings. It's made of steel. In motor, how the shaft will operate? It The shaft rotates the load. Okay, the load indicates that fan, pump, etc. Okay, but what about generator? It rotates, shaft rotates the armature because of generating electricity. Okay, then what's the next one? Types of DC machine. So many types are there. We can say self-excited DC machine and separately excited DC machine. Okay, so these are the various type of DC machine. Simply we remember that two types, that is separately excited DC machine and self-excited DC machine. In that self-excited DC machine, so many types are again available. Shunt wound or shunt machine, series wound or series machine, compound wound or compound machine. These three are present in the self-excited DC machine. We can simply say that it is a self-excited DC machine. Okay, so let us explain one by one. Separately excited DC machines, the field winding, which is powered by a separate external source. Okay, that is field current comes from another power supply, not from the machine itself. Okay, but in self-excited DC machine, the machine uses its own generated voltage to supply the field winding. There are three types of self-excited DC machine: shunt machine, series machine, and compound machine. Shunt machine, okay. In shunt machine, field winding is connected in parallel. The main feature is it provide a constant speed. Okay, where we used this shunt machine, fan, lathe, etc. Okay. What about series machine? If it is connected in series, we can say series machine. Okay, sorry. So what's the main feature here? High starting torque used in crane, traction, etc. What is torque? You know force, right? If the object is moving straightwards, we can say that is a force, or pull or push, we can say that is force. Okay. What about torque? Whenever the rotation, in rotation also we need one force, right? That force is torque. Okay. Then compound machine. In compound machine, again, this is the combination of both series and shunt. For better or balanced performance, we are used to this compound machine. Okay. Then next one, EMF equation. See, these are the parameters we are used to find the equation of DC machine. Okay, what are the parameters? Let phi be the flux. What is the flux? What is the unit of flux? Weber. Okay. Then next we used the parameter as P. The P is the number of poles. Okay. What is Z? That's the number of conductors used in the armature. Then so uh, small n, which is the rotation speed, okay, for each second, and a is the number of parallel path or parallel lane throughout the armature among opposite polarity brushes. Okay, Z by is the number of armature conductor within series for each parallel lane. Why we used this EMF equation? It's the mathematical expression to calculate the EMF induced in a DC machine. So you know these are all available due to that Faraday's law of equation, right? So what is Faraday's law? EMF is induced, right? Whenever flux change in the conductor, so EMF is produced, electromotive force is produced to know how much EMF is induced. That we calculate using EMF equation. Okay, so the amount of EMF induced in a conductor depends on the number of turns, right? So derivation, how to derive this we are considering a motor with p number of poles and n number of conductors. Okay, the spinning or rotation speed radial per second. We are consider the flux phi is produced according to Faraday's law. This is directly proportional to d phi by dt. Okay, the above equation will be explained that so the flux is directly proportional to, or energy is directly proportional to flux with respect to time. Okay, so we know how the time is explained. Dt is equal to 60 divided by n. The overall EMF is given in the equation. See the equation. Okay, now so using this formula, we will find the EMF equation. This is the actual formula used in that EMF. Okay. Then DC machine versus AC machine. What is the main difference between DC machine and AC machine? Okay. So for DC machine, direct current is used. What about AC machine? Alternate current is used. Okay, how it construct for DC machine, commutator and brushes are important, but in AC machine there is no commutator. Okay, then it's due to, so in DC machine we used commutator and brushes, that's why its maintenance is high. But if we use AC machine, its maintenance is low. Okay, then what about the cost? It's more DC is more expensive, but AC is cheaper. That's why so many times we are used that AC machine. Okay, then what about efficiency? It's lower only compared to AC machine. Okay, starting torque, DC machine is high, but AC machine have moderate. Okay, application, crane lift, this is for DC machine, and fan for AC machine. Okay, shall we move the next slide? Right. Losses in DC machine. Losses, from the name itself we understand some some something is reduced, right? So if losses is occurs in DC machine, it will affect the apparatus efficiency. Okay. So what are the losses present? We may say that electrical losses are copper loss, core loss, otherwise iron loss, mechanical losses, brush losses, and stray losses, etc. Okay, then so many advantages are present here. If you used a DC machine compared to AC, some disadvantages are there, even though so many advantages are present here. DC machines like DC motors have various advantages like starting torque is high, reversing, fast starting and stopping, changeable speed through voltage input. Okay, these are very easily controlled as well as cheaper when compared with AC. Okay, speed control is good, torque is high, operation is seamless, free from harmonics. Harmonics, that is distraction or disturbance. Okay, installation and maintenance is very easy. Okay, okay, these are about what DC machines. Okay, so DC machines, maybe DC generator or DC motor, both are DC machines because both the constructions are same. So here we saw that how, what are the parts present in DC machine and how it works, right? So the main principle is electromechanical energy. Have you remember what is that electromechanical energy? It's the energy conversion between electrical energy and mechanical energy. You know what are the main principle we used here? Electromagnetic induction and Lorentz force, right? Then what are the main parts present in DC machine? Yoke, then stator and rotor, that's the main part. Stator, stationary part, rotor, rotational part. So many stator, the constant parts are there, that is yoke, then pole shoe and poles, Then another one, what's that? Field winding. Okay, so yoke is the outer part. Okay, have you remember outer part? It provides the mechanical strength. How it made of cast iron or steel. It supports field system. Pole shoe and pole core. These are the main parts present here. Present in state. It's the parts of DC machine. It produces magnetic flux, supports field winding, and help in energy conversion. Okay, pole core that's the central part. Pole shoe, that is the bottom part of the pole. Okay, then field winding. Field winding is the coil that produces magnetic field and current flows through it, right? Next, what's that? Armature core. So in field winding, so many field windings are there: series field winding, shunt field winding, compound winding. Then next, armature core. These are rotating part of. These are the rotatory system, system. Okay, armature core, armature winding, etc. So armature core. Um, the main purpose is provides the magnetic path and reduces the eddy current loss. We explain what is eddy current loss, right? Next, armature winding. So armature winding, the armature rotates inside the magnetic field. Okay, it cuts the conductor cuts the magnetic flux according to Faraday's law. Two windings are there: lap winding and wave winding. The next, commutator, it's the mechanical device. And this commutator, what is the main purpose of it? Generate AC internally. Okay, and the output will be the direct current, DC. Okay, brushes collect or take the current or supply the current. Okay, so generator, the brushes will do one type of action, and in motor the brushes do another type of action, right? The next is shaft. We studied, you know what is shaft, right? And so many types of DC machines are there: field separated excited DC machine and self excited DC machine. Okay, so these are DC machines. I think you all understand. Thank you.